Okay, relative to the origin, 2 points of O, A, and B have the position vectors given by A and B respectively such that they are non-zero and non-parallel, and the magnitude of A is equals to the magnitude of B. Okay, so on the first part, I want to show that A plus B dot A minus B equals to 0. Okay, so you must remember that when you are showing the question, nothing is obvious. So you really need to expand every question, every part of the question carefully. Okay, so here you need to expand that this is A dot A, right, minus A dot B plus B dot A. So you cannot assume that they are the same right away. Okay, so some of you actually straight away write mod A square minus mod B square equals to 0. So remember that in proving, try not to skip steps. Okay, so this is with that, the next step, okay, A dot A minus A dot B. Now since you know that A dot B is the same as B dot A, we can write it in this manner, and you have B dot B. Okay, so cancelling off these two vectors, I mean the two scalar product, you end up with A dot A, which A dot A is the same as the square of the modulus of A minus the square of the modulus of B. And you know that since the magnitude of A is equals to the magnitude of B, therefore this is equals to 0. Okay. So next part, you have to give the geometrical interpretation of the result shown in part 1. Okay, so what do we do? Okay, if you want to show based on the results in part 1, you know that in part 1, A plus B, right, basically is a vector that is perpendicular to A minus B. Okay, so if we were to think about how they look like, okay, when we talk about geometric interpretation, let's try to think whether it's possible that the two of them form any shape. So this is A, this is B, right? Do you remember in the vector law addition, what is A plus B? A plus B will form the diagonal of the parallelogram, okay, that is formed by A and B. Okay, and what is A minus B? Of course, some of you may write A minus B in many different ways. Some of you may write it, for example, this way. You may write it as A minus B in this way. Okay, and you realize that A minus B can also be written as this vector over here. Okay, so if we are saying that in this so-called quadrilateral, right, you have the diagonals to be perpendicular to each other, right? And you also know that mod A equals to mod B, and you know that the diagonals are perpendicular to each other. So what can you actually deduce? This is nothing but becomes a rhombus. This one actually becomes a rhombus because in a rhombus, exactly in a rhombus, all sides are equal, right? Adjacent sides are equal, and the diagonals actually are perpendicular to each other. Right? That is why we can say that. I mean, if we denote C, let's say I call it C. If we denote C as the point such that if OC is the same as OA plus OB, then the diagonals of the rhombus, okay, here we can say it's a rhombus and not a parallelogram because the magnitude of A and B are equal, alright? So this and this are equal. Because O, let's say this is A, I call this B, I call this O, O, A, C, B are perpendicular. So this is the geometrical interpretation that we will give. Okay, the fact that they are, the diagonals are perpendicular, the magnitude of A and B are equal, so this and this magnitude are equal. Okay, so that's the geometrical interpretation. Now suppose mod A and B equals to 1. Okay, I want to show that A dot B square and A cross B square is equals to 1. So there are a lot of ways to go about doing this. Okay, one very quick way would just be to use Pythagoras theorem. Okay, so if I were to look at A and it's got B, this is A, this is B, right? So you recall that this portion here, that this will be basically A dot B hat, right? The length here will be A dot B hat, and the length over here, right? We're talking about the length, will actually be the modulus of A cross B hat. Okay, however, you must remember that in this question, they're going in part 3, they told you that the magnitude of B is equals to 1. So what does it mean? It means that in this case, right, B is already a unit vector. In this case, right, B is already a unit vector because B is equals to 1. You can say that. So if that's the case, right, for this particular question, okay, we can just erase away the B hat. We can just erase away the B hat. Okay, so if you observe, what do you see here? It's actually nothing but sincere looking right angle triangle, which are related by the adjacent, the hypotenuse, and the opposite. Okay, so using Pythagoras theorem, very quickly, alright, the square, sum of squares of the adjacent and opposite should give you the equate to the square of the hypotenuse. Alright, in the question you also know that here the magnitude of A equals to 1, so it means that here this is equals to 1, so the length of the hypotenuse is equals to 1. Alright, and with that you have A cross B square plus A dot B square to be equals to 1. Okay, and we are done with question 7.